Okay, let's talk about horizontal asymptotes and rational functions. So what we're going to do is we're going to be using a test where we compare the degree of the numerator and the degree of the denominator on each one of these. We're going to run through like 9 examples real quickly right here, figure out if it's going to have a horizontal asymptote and exactly where it is. All right, so in comparing these, we want to look at the highest power of x. In our case, it's x is our variable in the numerator and the denominator, and compare them. Either the numerator is bigger, the denominator is bigger, or they're equal. As you can see, I have listed at the top exactly what we're going to say is the rule for each one of these. So jumping right in on this very first one, we're comparing the highest power of x in the numerator and the denominator. You'll notice these are the exact same, so it's the bottom of these rules where they're equal degrees. They're each degree 2. So in this case, it's going to be y equals the ratio of leading coefficients. So the leading coefficient is the number out in front of the highest power of x. In the numerator, we don't see a leading coefficient. It's automatically a 1 out there. So 1 over leading coefficient for the denominator is 3. So y equals 1 over 3 is its horizontal asymptote. In the middle, we're comparing 3 and 2. In this case, the numerator is bigger than the denominator. So what we're going to do is say that we have no horizontal asymptote. Now, technically, there's an oblique asymptote or a slant asymptote in this case, but we're not going to worry about that for our purposes. All right, moving along here, the next one we have 2 over 2. Again, this goes back to their equal, so we're going with the bottom. All right, the ratio of leading coefficients. In this case, they have these 1s hanging out in front. We just have to know they're there. So it's y equals 1 over 1. 1 over 1 is y equals 1. Continuing on, let's compare. We have x plus 1 over x squared plus 2. We have to remember there's automatically a 1 up there in the exponent. So 1 compared to 2. This time the denominator has a bigger degree. So it's automatically at y equals 0. In the middle, we have 3 over 3. Those degrees are equal, the exact same exponents on the highest power of x. So we go ratio of leading coefficients. We have 6 over, remember there's a 1 automatically in front of that x cubed in the denominator. So we have 1 at y equals 6 over 1, or y equals 6. Next up, we're comparing 2 and 3. In this case, the denominator has a higher degree. Remember, it's not the numbers in front you initially compare, it's the degree, the highest power of x. So in this case, denominator is bigger. That automatically means y equals 0 is going to be our horizontal asymptote. Continuing on here, back bottom left, we're looking at 3 and 2. This time the numerator has a bigger degree, so we say we don't have a horizontal asymptote. Again, this may be a slant asymptote or oblique asymptote, but we're not going to worry about that. Middle, we have 2 and 3. Denominator is bigger. That's automatically y equals 0. And then finally, we're comparing 3 and 2. Numerator is bigger. This is where we say we don't have a horizontal asymptote. All right, hope this helps out as we're just comparing degrees of numerators and denominators. I know we went through it pretty quickly, but get these 3 rules down. They're pretty handy to know about. Good luck.